In this argument, we're going to look at standards for evaluating arguments. We want to be able to answer the question in as precise a way as possible, what is a good argument and what's a bad argument? Okay, so remind ourselves, what is the actual definition of an argument? An argument's a set of statements, at least one of which is a premise or a reason to believe another statement, which is the conclusion. The premises, crucially, are supposed to provide support for the conclusion. Arguments involve giving reasons. Let's introduce another bit of jargon that is common when talking about arguments, and that is inference. When we move from a premise or premises to a conclusion, we make an inference. For example, from the fact that the door is open, I might infer that Jose must be home. And the argument in standard form would look like this. The door is open, so here's my conclusion indicator word to indicate this is supposed to follow. Jose must be home. Or I could map it. Jose must be home. Why think that? The door is open. The premise is the basis for the inference. The conclusion is the product of the inference. The inference is the move from premise or premises to conclusion. So an inference is essentially the arrow. Finally, we can introduce criteria of goodness of arguments. What makes an argument good is that the inference from the premises to the conclusion is good. Seems like I have more explaining to do, but stick with me. The inference is good. The premises provide good support for the conclusion, and 2, the premises are all true. So here are our 2 basic criteria for argument goodness. The premises are true, and they provide good support for the conclusion. Notice I defined good in terms of good support. Hang on to that. Let's just stick with what we've got so far and move on to each of our criteria. So let's start with criterion number 2 in our list, true premises. In order for an argument, the whole package, to be any good, the premises have to be true. Consider the following example. Playing violent video games causes children to become violent, thus violent video games should be banned. Here it is in standard form, here it is mapped. In order for this to be a good argument, we have to have true premises, right? So we need to ask, is this premise actually true? Is it true that playing violent video games causes children to become violent? And if our argument is to be convincing, we're either going to need to give good reasons for believing this premise, like are there studies or what, or the premises need to be acceptable to anyone we're hoping to convince with our argument. But if we're being philosophers and not trying to just win, but trying to get at knowledge and truth or something like that, we're not just trying to be persuasive and to win. We want to know, is this really a good reason to believe the conclusion? Is it actually true? So we might need to go further. One thing worth noting, as a general rule, in order to find out if premises are true, we need to know stuff about the world. To figure out if playing violent video games actually influences violent behavior, we've got to study kids and video games, or we've got to actually read the studies and know how to read studies, and that means evaluating premises is sometimes quite difficult. But let's move on to criterion number 1 on our list, good inferences. One crucial feature for a good argument is that the inference from the premises to the conclusion is good, that the premises actually support the conclusion. And note, even if we don't know whether or not the premises are actually true, we might be interested in whether or not they would support the conclusion if they were true. Consider, for example, either Anat ordered pepperoni pizza or they ordered cheese pizza. Anat did not order pepperoni pizza, thus it follows that they ordered the cheese pizza. Now, I don't know if either of these premises are true. I don't know Anat. I don't know if they ordered any pizza. I don't know what kind. But I do know that if, emphasis on the if, these premises are both true, then the conclusion is definitely true. And we can extract a general form or pattern of reasoning here, either A or B, not A, thus B. Here's a map version of it. And again, I don't know what A and B stand for. I don't know the content of the argument. I don't know if the premises are actually true, but I do know that if both premises are true, the conclusion must be true. The conclusion follows from these premises. The premises provide watertight support for the conclusion. So these are things that I can say about the inference or the reasoning. Side note, sometimes when we are trying to figure out what follows from things we believe or from a scientific theory, for example, what we care about, like we don't always know if the thing we believe is true, if our scientific theory is true, but we might be interested to know if it were true, what would follow, so we can go and observe, does that thing actually happen? Because if it turns out that if our theory were true, we should observe X, but we don't observe any X's, that tells us something about our theory, right? So we want to know what follows from what we believe, even if we don't know whether the premise is, the starting point is itself true or not. Okay, so we've got two new standards we're going to introduce here, deductive and inductive standards. Anytime we want to say, in a careful, rigorous way, what makes something good, we need to say what the standards are. Whether we're talking about judging movies or potato chips, if you want to say it's good or it's better than some other thing, it's an ideal we should aim at, what are the standards of goodness we are using to assess that goodness? So what makes a potato chip good? Well, what do we want in a potato chip? Crispiness, saltiness, etc. And maybe there's more than one relevant standard. So maybe we should hold healthy and not so healthy potato chips to two different standards. There's a standard of goodness for unhealthy potato chips. You definitely want to have MSG and lots of fattening oils, delicious potato chip on this standard. But if what you care about is what's the standard for a good potato chip if you hold it to this other standard? So similarly, we're going to identify two standards for evaluating inferences or arguments. Standard number one, let's for now call it the guarantee standard. The premises, if they were true, would 100% absolutely guarantee that the conclusion is true. Emphasis on the if in if the premises were true, and emphasis on the guarantee. Here's another way to put it. It's impossible that the premises could all be true and yet the conclusion could be false. Emphasis on impossible. So on this standard, when we say, if an argument is good, it better have a good inference. The premises better provide good support for the conclusion. When we say good, we mean perfect. We mean a guarantee. And our previous example, and here's another argument of the same abstract pattern. Either the Golden Gate Bridge is in San Francisco or it's in San Diego. It's not in San Diego, thus it's in San Francisco. If these premises are true, then the conclusion has to be true. The premises guarantee the conclusion. Now let's look at an argument that has false premises but still meets the guarantee standard. Either the Golden Gate Bridge is in San Diego or it's on the moon. It's not in San Diego, therefore it's on the moon. This argument has the same underlying structure or pattern as the previous one, and so when it comes to the inference, it is equally good. The difference between these two arguments is that this one doesn't have true premises, whereas this one does. But the inference is still good. It still gives you a guarantee. If the premises were true, they aren't, but if they were, the conclusion would have to be true. The premises guarantee the conclusion. And that means the support relationship or the inference is good. Again, argument not good because it doesn't have true premises, but support relationship good. Now there's another standard. That's a pretty high bar. An argument is only good if the premises guarantee that the conclusion is true. That's a high bar. So that's going to rule out a lot of arguments from the possibility of being good. So we might instead hold arguments to something less than a guarantee standard. Pretty vague. Take note. But let's move on. The premises, if they were true, would make it likely that the conclusion is true. Here's one way to think about something less than a guarantee standard. So on this standard, we're okay with the possibility our conclusion could be false. What we care about is that the premises give us reason to think the conclusion is probably true. We want really good, but not necessarily foolproof reasoning. Now, why settle for less than a guarantee? Because guarantees aren't always possible. More on that later, but this one will do well enough to illustrate the basic point. Consider the following argument. My window is broken, my computer is missing, all of my drawers are ajar. Best explanation is that I have been robbed, thus I have been robbed. In this case, the premises, if they are true, make the conclusion likely, but they don't guarantee it, because it's possible that both of these premises are true. The best explanation really is robbery, and all of these observations really are the case, but maybe I'm being punked, if that is still a thing. Now, why I said 100% guarantee isn't always possible? Why isn't that possible? What would it take to turn this into an argument where the premises guarantee the conclusion? Well, I could add one more premise that says, and if an explanation is the best explanation, then it's definitely 100% true. But that premise would be false. So I could get an argument where the premises guarantee, but only by adding a false premise. That will sometimes happen. So you can't always have 100% guarantee and true premises. More on that later. Now, our previous argument didn't give us a guarantee, but it seemed pretty good. Compare with this example. The Golden Gate Bridge is in San Francisco. J.K. Rowling is the author of Harry Potter, therefore, thus, cats have paws. In this case, the premises and conclusion are all true, but the premises don't provide any support for the conclusion. So this inference doesn't meet either standard. It is clearly a bad inference. And now we're going to give things names. We need more jargon. So deductive arguments are arguments that purport to meet the guarantee standard. Arguments that can or should be held to the guarantee standard. Inductive arguments we are going to define as arguments that purport to meet the something less than a guarantee standard, but still good, or any argument that can or should be held not to the guarantee standard, but to the something less but still good standard. Note, for our purposes, inductive equals not deductive. Guarantee or something less than a guarantee. Other sources may use something specific when they talk about induction and inductive arguments. They might talk about reasoning from observed cases to unobserved cases, and we'll look at those kinds of examples too, but for jargon purposes, when we say inductive argument, we're just going to mean not deductive. Premises do not guarantee conclusion, but do provide good support for the conclusion. There's that word good again. And so let's end with more definitions and jargon. So we said a deductive argument is an argument held to deductive guarantee standards. And these standards include, new bit of jargon, validity. An argument is valid if the premises are or were true, they do or would guarantee that the conclusion is true. This is what we mean by valid. This is just the guarantee standard. If the premises are or were true, they do or would guarantee that the conclusion is true. And we'll say an argument is sound if it is valid, plus it has the true premises. It meets both criteria. And an inductive, where we mean not deductive argument, is an argument held to inductive standards. And those include the something less than a guarantee standard we're going to call strong. If the premises are or were true, they do or would make it likely that the conclusion is true. So we'll call that strong. And an argument that is strong and the premises are actually true, we will call cogent. Okay, and here's a little chart of jargon. Deductive arguments. Step 1, does it have a good inference? Then yes, it's valid. Does it also have true premises? Yes. Well, then it's sound. For inductive arguments, does it have good inference? Do the premises make the conclusion likely? Then it's strong. Is it strong and also the premises are true? Step 2, yes, then it's cogent. So here are our 6 bits of jargon. Deductive standards versus inductive standards, validity and soundness, strength and cogency. Finally, let's end by looking at definitions of bad arguments. So, an invalid deductive inference is just an inference that purports to guarantee the conclusion but doesn't. It looks like it's invalid. People will incorrectly identify it as invalid, but it's definitely not, as valid, but it's definitely invalid. It's not valid. So here's an example we've seen before. All roses are flowers, some flowers are red, thus some roses are red. This example often confuses students. They are inclined to judge that the premises do guarantee the conclusion. If the premises are true, the conclusion must be true. And this one is confusing perhaps because the premises and conclusion are all true, and one way that we go about evaluating arguments is we just say, does this all fit with stuff I already believe? Checks out. I'm not going to investigate this further. But if you stop and try to scrutinize it and ask, wait, is it possible I could be wrong? Is it possible these premises could be true and yet the conclusion doesn't follow? We'll find that the answer is yes, it is possible. These are true and yet this is false. This does not meet the guarantee standard. Here is an argument that has the exact same underlying pattern of reasoning. People aren't confused about this one, though. All humans are mammals. Some mammals have tails. Thus, some humans have tails. The fact that the conclusion is obviously false, presumably, flags to us that something has gone wrong, and we can go back and spot what the error is pretty quickly. True, all humans are mammals and some have tails. Humans just aren't in the category of mammals with tails, like cats and dogs are. But humans are mammals that don't have tails, because only some, not all, mammals have tails. Similarly, all we've been told here is that roses are flowers, and that some, but perhaps not all of them, are red, and maybe roses are in the camp of non-red flowers. That's possible. Now, this is actually true, but it's possible that these could be true, and yet this could be false. So this isn't valid. The premises don't guarantee that the conclusion is true. The conclusion is not said to follow from the premises. And we'll call that an invalid argument. Not only is it true that the conclusion doesn't follow, it also seems like it's supposed to, and people are confused about it. Hence, we'll call it invalid. It fails to meet the invalid standard, or the standards of validity. A weak inductive inference is just an inference that purports to provide good support but doesn't. And so here are some examples that people might think are convincing where the premises don't actually provide very good support for the conclusion at all. Certainly not a guarantee, but not even good support. So a kind of thing sometimes I hear people say is, oh my god, guys named Steve are so crazy. I used to work with a guy named Steve and he was like nuts. Okay, so if we distill that, the claim is just, there's an example of one Steve who is crazy. I used to work with a guy named Steve who was crazy. We could cut some of this out and just be like, there's one guy named Steve who was crazy. Therefore, guys named Steve are crazy. That seems like a bit of a jump. This is a sample of one, hard to generalize here. So this is going to be a premise that doesn't provide very good support for the conclusion. How about Steve likes to read, Steve has a cat, thus Steve is an introvert. Again, it seems like these are not the kinds of, lots of people who read and have cats are introverts, and there's a stereotype about that, but lots of people who read and have cats are also wildly extroverted. And so this seems like not a very, I wouldn't bet on this. If this is all you know about Steve, I wouldn't bet that he's probably an introvert. There's a good chance I'm going to lose money on that bet. And that's one way to sort of evaluate how much support do these premises give to the conclusion. Not much. Finally, how about something like this? I broke out in hives immediately after I got off the phone with Steve. Thus, I've been given a sign from the universe that Steve is bad news. This bit of reasoning leaves a lot implicit. So, the fact that I'm concluding that Steve, just leave aside the sign from the universe part, but just the fact that I'm concluding that Steve is bad news, that seems to suggest that Steve, or talking to him on the phone, caused my hives. So there's clearly some claim about causation being made here. And I'd say that it probably goes, thus, talking to Steve caused my hives, thus I've been given a sign from the universe that Steve is bad news. Okay, so some reasoning about causation seemed implicit here. All I cited before is immediately after I got off the phone, I got some hives, Steve is bad news. Well, I must have been assuming that Steve caused my hives on the basis of them appearing immediately after I got off the phone with Steve. So there's an implicit inference involving causation packed in here. This only makes sense if I've implicitly inferred that he was the cause of my hives. Now, and I could probably convince myself that this makes sense for reasons. Maybe hives are a stress response and Steve is a stressful dude. But all I've really been given here, the main sort of source of my inference, is a correlation. One thing happened after another. And the fact that one thing happened after another is not very good support for a causal claim. We might want to do much more. Even if we have a bit more, like it makes sense that hives are a stress response and Steve is stressful, it's still pretty weak. Right, so what are the standards for drawing conclusions about causation? That's something that we'll look at in more depth. What are the standards for generalizing from a sample? Again, those are a set of standards we're going to look at in more detail later. For now, our point is just that these premises don't provide very good support for the conclusions drawn, and they are examples of weak inferences or weak arguments that we hold to inductive standards and they don't measure up. One final note, all inductive arguments are technically invalid in the sense that their premises don't guarantee their conclusions. So consider the example where I observed my laptop being gone, my window being open, my drawers ajar, and I conclude that I've been robbed. That's technically an invalid argument. Would we want to say that that's a bad deductive argument? That seems like a weird thing to say because it was never trying. It's weird to think of an argument trying to be deductive. It seems like holding an argument like that to deductive standards, those are the wrong standards to hold that argument to. But we could, and if we did, we'd say, well, yeah, it's invalid. And I analogize that to calling me a bad basketball player. That's totally true. But I wasn't telling everyone I was really good at basketball. Nobody was ever confused about my being good at basketball. No one ever thought that was true. So you could call me that, but it would be weird. And likewise, we can hold any argument to either standard, and if we hold a good inductive argument to the deductive standard, it fails to measure up, but it's not clear why that should reflect poorly on the good inductive argument. Okay, in this video, we have asked the question, what's a good argument? What are the standards for evaluating arguments? And we've introduced two sets of standards, deductive and inductive standards.